Hello, ladies and gents, and welcome to the third episode of our introduction to Java game programming. And in this episode, we are going to get an introduction into variables. Okay. Now, what exactly is a variable? A variable is a way of storing data in the computer's RAM. Now, the way we do that is we can store it into data types, as they're called, so different specific sizes of data. And the reason we want to do that is so that we can reference numbers. We can store numbers. So the player's x coordinate is stored in a variable called x, and you can modify the variable x and move the player around the screen. Right? So we're going to make our very first variable with the data type of an integer. Now an integer has no decimal places. So let's say int, right? Int is our data type, and you can see it turns purple, and we'll add a space after that. And now we need to give our variable a name. Now I'm going to name this number. So the name of our integer is now number. And I'm going to set this equal to 5. Okay? And don't forget your semicolon at the end. So now I have a place in my computer's RAM. I named it number, and it'll store integers there. And I'm storing the integer 5. So if I go to system.out.println, and I printline number, and then I give it a quick run, I get out 5. So it printed out our number 5. Right? Now, our integer can only store whole numbers. It can't store decimal places. So if we want to store a decimal place, we need a data type that'll store decimals. So I'm going to type float, and I'm going to name this number with decimal. I'm going to set it equal to 9.2f. Now float is short for floating point number, which is this big computer science concept of just numbers with decimals. If you wish to learn more, you can Google floating point numbers, and there's a whole bunch of stuff you can read up on that if you wish. So, remember in the past how we just had the period and then the decimal? Well, for floats, we have to specify that it is a float and put an F at the end of our decimal. So now, we're going back to our math class. We can use these variables as basic like numbers, and we can add them together. So I'm going to add number with decimal. So number plus a number with decimal, right? If we run it, we get 14.2. Or I can multiply it and get 46, right? We can treat these exactly like we would treat any other number, because that's what they basically are. They're referencing a number or a place in memory where we stored data. We stored a 5, or we stored 9.2f. Okay? The next data type, as I showed you, floats require the f. Before we didn't have that. Before, we were using what are known as doubles, right? And with doubles, we don't need to specify there's an f there. And if we run it, we still get the same answer. But if we say divided, instead, we get this big long decimal place. Change this back to float real fast. Remember how big this is? If we run it again, we get a decimal, but it's a lot smaller in comparison. The differences between a float and a double is a float only has 32 bits of memory, while a double has 64 bits of memory. Now, you don't need to exactly know what that means or entails. just know that a float has less significant figures than a double. A double stores more significant figures. Remember significant figures from chemistry? Well, you're using it again, but in computer science. So we're going to leave this at a float. Now, what if we wanted to store, say, characters, like keys? I want to store the letter F, right? There is a data type called character, or char, or car, or however you want to pronounce it. And we can store it, so we'll say letter equals, now we want to use apostrophes, and we'll say H. So in our data type char, the name letter, we are storing the letter H. Now you can only store one Unicode variable, or in layman's terms, letters, in char variables. What if I want to type out a whole string of characters, a whole bunch of characters together? Well, there is a data type that's not technically a standard or primitive data type, as these are referred to as. It's called a string. And I'm going to say string text equals quotation marks hello. Right? So a string is a bunch of chars in a row. Right? Remember before when we printed out game over, we put it in quotation marks. The quotation marks means it is a string variable, while the apostrophes means it is a character variable. So now we can actually print this out alongside this. So I'm going to say text plus number divided by number with decimal, right? Now, it's not going to treat our string, our text of hello, like a number when we're adding it. This is known as conjoining. There's a special word for it. I'm blanking on it right now. Forgive me. But we're basically tagging on the text. So when we print it out, it'll say hello and then our number. Our number divided by number with decimal. So because it is a string, it doesn't treat it like a number. Instead, it conjoins them. So there we can store text, right? There are also other forms of storing integers and floats. So we got our integer, which is a 32-bit number. Now there is a way of storing 64-bit numbers, 64-bit whole numbers. That is stored as a long. So a big number. That's equal to a whole bunch of numbers, right? Now, just like with our floats, how we had to put an F at the end, for our longs, we have to put a big L at the end. And that'll tell the compiler that we are using a long number and to store it as a long number. Right? So a long number can hold a lot more, a lot bigger number than an integer. How much bigger? Well, let's actually find out. There is a way of seeing how big your integers and your longs and all the other data types can be. So the way we can do that is we can type big I integer, and we can hit dot, and then right at the very top there you see max value. We want to get the integer dot max value. Okay, so if we run this, it'll print out the maximum value of an integer. An integer cannot be bigger than this number. If it goes bigger than this number, it'll actually loop around and go negative. Now, so if I say integer.maxValue plus 1, this should go negative. And it does. So, by adding 1 to that, it reaches the maximum value an integer can hold. And it wraps around and goes negative. So now it's negative the maximum value an integer can hold. That is something very important. to remember about data types is there is a ceiling. And if you hit that ceiling, well, it'll loop around. So we have how big our integer is. Let's find out how big our long is in comparison. So I'm going to copy this, Control C, and I'm going to paste it, Control V. And I'm going to change the integer to long. So I'm going to use the long data type. And now if we run it, we have the maximum value of an integer on top and the maximum value of a long on the bottom. Look how much bigger the long is compared to the integer. It is enormous compared to our integer. If you were, say, making cookie clickers, you will want to use a long for your number of cookies rather than an integer, because you can store way more cookies in your long. Okay? Now, you can do these for the other ones, if you do not know. The other number, I'm going to list these out for you guys real quick. The other number data types, they're the double, so number with, I'm going to say, bigger number with decimal equals 5.0. And we have smaller data types than an integer. An integer is 32 bits. We have a byte, small, equals 4, which is only 8 bits of memory. And we have a short, which is kinda small, which equals 200, which is 16 bits of memory. Okay? So these are our main data types that we're going to be using. There's another data type which we will get into once we get into our if statements. But for right now, these are our basic data types and variables. Hope this was informative. Comment, rate, subscribe, and thanks for watching.